Hello viewers, welcome back to the part 10a. That is a continuation of creating a function in F7. Let's get started. Okay, so we'll move on to the main screen and then have a look at getting started project. It's already open. So in the first part of the creating function in F7, step 7, we created a function to organize our elevator code. And in this part, we'll create a function where we'll assign inputs to this function and output as well so that we can reuse this function over and over again. So let's get started. All right, so we'll go to OB1. In the OB1, we have our elevator function right here. So now we will create a function that is going to be a time delay. This time delay will be applied to our petrol and diesel engine in such a way that whenever you start the engine and then you stop, the engine fan will implement a fan that is supposed to cool the engine. This fan has to run for 20 seconds before the fan goes off whenever the engine stops. So to do this, we need to create a new function. So we'll move to the main schematic manager interface. We go to insert new object. We click on function. So this is our function 2. Okay, then we call this function as a timer function. So function. Okay, it's in ladder. We click on OK. So we've created our second function. We can double click on it now to open. So we have our function right here. Let me drop this a bit. So we have our local variable declaration point right here. So now we need to specify the inputs that we will need for this particular function to work. So first, we need to detect that the engine is running. So we need an engine on command coming in. So this is going to be our engine underscore on. And the data type is going to be a bool. And then we can add our comment. So we can say signal for switching on engine. Okay, so we have this one right here, and then our next is going to be the input that is going to take our timer address. We can call it timer underscore function. Now this data type, because it's going to accept our timer, is going to be a timer function. Okay, so we have these two inputs. We move on to our next, that is going to be our output. And then our output is the one that is going to control the fan. So that is going to be our fan underscore on. Okay, this is going to be our fan control command. Okay, so now we have our inputs, that is the engine on, and then we have the timer function right here. And then when we come to the output, we have our fan on also here. So now we'll move ahead and then implement our logic. So basically this is going to be our timer logic. Okay, so what we need in this logic, first we need the timer block. So we move to timers, we drop it, and then we have various type of timers, but basically we are looking for the off delay timer. So this right here, I'll drag and drop it. Yeah, okay, so now we have the set. This is where you set the timer to start counting, and then this is where you reset the timer. Basically we are not going to make use of the reset, but we'll be making use of the set. So what's the condition for us to start the timer? The condition is when the engine starts. So we have our engine on signal coming here. So we put a normally open contact right here, and then we give it the address engine on. So we have our engine on signal coming on here. So whenever the engine comes on, then we can set the timer to start counting. Then we give the preset time, which is S5 timer, that is S5T hash, and we are going to set it at 20 seconds, so 20x, and then we click OK. And then now we have to give it the specific variable that is going to accept the timer name. Okay, so we have the timer function right here, so we can copy and paste. Okay, so we have the timer function assigned to it, and then whenever the timer finishes counting, it needs to energize an output for us, and that is to turn the fan off. So immediately the engine goes off, the output will still remain on for the preset time, and then it goes off. So we'll put a coil right here, and then this coil is going to be our output. So I'll move to output, and it's going to be the fan on. Okay, so believe it or not, this is all what we need to do to get our timer function. Okay, so from here we can now save. Okay, so the next step is now call this function in OB1 and then make use of this function in our diesel and then fuel engine example that we did previously. Okay, so I'll go to Windows. I minimize this one, go back to the schematic manager, and then I can start OB1. Okay, so we look into OB1, we have a petrol engine, then we have our diesel engine. Okay, if we look at our drawing right here, you can see that I've added the fan to our circuitry, and it's connected to input Q6. Okay, so this is OB1, and then from here we can call the function that we just created. That is the timer function that we just created. So I will insert a new network under the petrol engine. Control R. This is going to be the fan control delay. Okay, so now that we've created the function, which is the FC, when we come to our FC block and we drop it, we should be able to see our function that we just created. So we have the function which is FC2. I'll drag and drop it in our network. Then we can see that the engine on input is right here. We have our timer, and then we have our output. Okay, so our engine on is going to be the signal from our petrol engine output. That is the command to turn the engine on. So I will select this one, copy, and then I can paste it right here. Okay, then we have the timer function. So this is going to be the name of the timer that we are going to make use of. Okay, so for now we can cross-check quickly and make sure that the timer that we are about to use, we've not used that timer already. So I go to cross-reference display. It's always important to do this so that you don't use timers that you've already used or memory bits that you've already used. So I'll come to assignment, input, output, memory, timers, and then counters. Okay, so I click on OK, and you can see that within this PLC I've not made use of any timer here. So I will start with timer 0. I can minimize it now, and I'll assign timer T0 to this. You can give it a symbolic name, so you can say edit symbols. This is going to be a petrol fan underscore delay. So that is going to be our petrol fan delay, which is a timer. I click OK. Alright, So the output is going to pick our timer. And remember, when we checked from our drawing, the signal is connected at 6 dots. Sorry, it's connected at dot 6. My last output was 3.5, so I can go to Q 3.6, and that is going to be the connection for our timer. So I can give it a symbolic name. This is going to be our fan command. So we can see that we've been able to call our function and then assign parameters to this function, inputs, and then also output to operate. And save. And because we will be making use of the simulator, I have to go back and turn on the simulator. So I turn on the simulator. So I have input bytes. I change it to 3. So I have to download all the program into it. So I can save. Go to my FC save. And I can download into the PLC. Downloaded. Come to my OB. I can save and then download my OB1. So I go back to the simulator and then I can put the simulator into run mode. Okay, so we can see that our simulator was not able to start since the download was not well done. So we'll use the second approach of download. Let me download all the blocks. So I highlight all the blocks. I go to Semantic 300 station, right click, go to PLC, then I say download. I'll push all the blocks into the yes to all. So it's telling me the model is in stop mode. I say yes, start. Let's see whether the simulator started. Perfectly, we can see the simulator start. Okay. So we can go back and then to our OB1 and then do our simulation. So I'll go online to monitor. You can see that the diesel engine output is off. It's not on now. So I'll go to the simulator. Our inputs. So the on switch is 1.7. The failure switches are all on. So change this one to 1. Then I need to add another input. So let me close this once. Add set input variable. This is going to be my 2. Okay. So we have a simulator right here. So we have input byte 1 and then byte 2 being our inputs, and then we have our outputs, that is 3. Okay, so we need to turn on our off switch because off switches, they are normally closed on field. So that is 2.0. So I turn it on, and then we can see that it's on here. We can see 2.1, which is our failure switch, which is also normally closed. So I turn it on, and then we can see our failure switch also on. Our auto selection must be off so that we are in auto mode, so that one is selected. Okay, so now I can turn the engine on, and then let's see what happens to the fan. So immediately the engine is turned on, which is 1.7. I tick, I can see the engine coming on. The fan also started because it's at logic 1 now. I need to untick because the start push button is momentary switch, and we can see that the engine is running right here, and then we can see the fan also on here. Now when I stop the fan, when I stop the engine, let's see what happens. So the stop push button, which is 2.0, I click 2.0, and we can see that the engine has stopped, but the fan is still running. So let's see, the fan needs to run for 20 seconds and then go off. So we can switch view. I'll go offline here, and then I'll switch to our function that we created, and then go online on the function, and then we can see that the output of the timer has gone up. So we'll simulate monitoring the function, and let's see what really happens. So I'll turn the system back on again. So 1.7, and then we can see our timer immediately comes on because the engine is on. And when I turn the engine off, we can see that we've lost the on signal coming to set the timer, and then we realize that the timer will count down. 20 seconds needs to go off. Correct. So within 20 seconds our timer goes off. Switch back to the OB1. So basically we've been able to create a function of a timer, a delay timer, and then we've called this function in OB1, and then also introduce this FC into our petrol engine logic. We'll also move on quickly and introduce the same function so that we will understand how reusable when you create an FC it can be. So I don't need to go through what we did previously. I just move on, and then I can recall the function and then use it. So I'll create a new network under the diesel engine. Then this is going to be the D time. Okay. So I can move to the FC again and call the function that we just created. Okay. So I'll assign the on command of the diesel engine to it, and then the timer. Remember, we've already made use of timer T0. We can't use it again. We need to move on. So I have to make use of timer T1. Okay. So I'll put the petrol engine, we put it at 0.6. We'll put this one at 0.7. So 3.7. So basically this is all what we need to do to also control the fan of the diesel engine. So I save, and then I can now click on download because I've already downloaded the entire. Okay, it's downloaded. So I'll go online, and then we can also monitor it as well. Okay, so we can see that the diesel engine, the switch off switch is 1.4, so I can take it on. And then we can see it's at logic 1. The failure is 1.5, so I take it on because they are all normally closed, logic 1. And then I can now look at the on signal, which is at 1.3. So if I tick 1.3 and I untick, I can see that my engine is on, it's at logic 1 now. The timer is also on at logic 1. So you can see that the same function, but we've been able to call it 2 times and then use it. It's at logic 1. And let's wait for now. When I go off, which is 1.4, you can see that the diesel engine is off, but the timer is still on, and it will remain on to 20 seconds, and then it needs to go off. So let's observe it. Okay, so immediately it reaches 20 seconds, we go back on. All right, so viewers, this brings us to the end of this part of our tutorial series. Being able to implement a delay function, and then we've been able to call it in OB1 and then implement it for our diesel and then petrol engine. Thank you for watching. I hope this helps someone out there. See you in the next video. Bye bye.